Hi all, I'm Pushp Sirohi and today we'll discuss about quantum computers. I hope you already know about computers like desktops or laptops, all known as computers. After then we come up with one more technology named supercomputers. Is a computer which have a high level of performance as compared to general purpose computers. The performance of supercomputers is commonly measured in flops, floating points operations per second instead of millions instructions per second MIPS. So, computers that perform quantum computations are known as quantum computers. Quantum computers are believed to be able to solve certain computational problems such as integer factorization, which underline RSA encryption. RSA's rivals Shamir-Ullman is an algorithm used by modern computers to encrypt and decrypt messages. It is an asymmetric cryptography algorithm. So asymmetric means that are two different keys. They are also called as public key cryptography because one of the key can be given to anyone, substantially faster than classical computers. A 30 qubit quantum computer would equal the processing power of a conventional computer that could run at 10 teraflops, trillion of floating points operations per second. Today, typically desktop computers run at a speed measured in gigaflops, billions of floating points operations per second. The overall quantum computing market is expected to grow US dollar 93 millions by 2019 to US dollar 283 million by 2024. So, how do quantum computers work? So, quantum computers perform calculations based on the probability of an object's state before it measured, instead of just ones or O's, which means they have the potential to process exponentially more data compared to classical computers. So classical computers carry out logical operations using the definite position of a physical state. These are usually binary, meaning its operations are based on one of two positions, single state such as on or off, up or down, 1 or 0 is called a bit. In quantum computing, operation instead use the quantum states of an object to produce what's known as qubit. These states are the undefined properties of an object before they have been detected, such as the spin of the electrons or the polarizations of a photon. Rather than having a clear position, unmeasured quantum states occurred in a mixed superpositions, not unlike a coin spinning through the air before it tends to your hand. These superpositions can be entangled with those of other objects, meaning the final outcomes will be mathematically related even if we don't know yet what they are. The complex mathematical behind these unsettled states of entangled spinning coins can be plugged into spatial algorithms to make short works of problems that would be take a classical computer a long time to work out if they could ever calculated them at all. Such algorithm would be used in solving complex mathematical problems, produce hard to break security codes, or predicting multiple particle interactions in chemical reactions. So, types of quantum computers. Building a functional quantum computer requires holding an object in a superpositions state long enough to carry out various processes on them. Unfortunately, once a superposition meet with material that are part of measured system, it loses its in between state in what's known as decoherence and become a boring old classic bit. Device need to be able to shield quantum state as decoherence will still make them easy to read. Different processes are tackling the challenge from different angles, whether it's use more robust quantum processes or to find better ways to check for errors. Quantum computing supremacy for the time being. Classical technology can manage one task thrown of a quantum computers. Quantum supremacy describes the ability of quantum computers to overperform their classical counterparts. Not everybody is convinced that the quantum computers are worth the effort. Some mathematicians believe that there are obstacles that are practically impossible to overcome, putting quantum computers forever out of reach. Time will tell who is right. Google and NASA reported that their new 1097 qubit D wave Quantum computers had solved the optimization problem in a few seconds, that 100 million times faster than a regular computer chip. They claim that the problem, their D-Wave 2x machine processing inside 1 second, would take a classical computer 10,000 years to solve. And as IBM already launched its quantum computer in market to support world to become more and more smarter, named IBM Q. Let's see how quantum computers will change our life. I hope you like it, guys. Have a nice day.